positive 12 minus negative 58. Two negatives to make that positive, making 12 plus 58. You're going to have 70 degrees difference between 12 degrees and negative 58. And I told you guys, this is like the situation where you're going to have like that really long number line, right? Actually, you know what? I can make it a little bit smaller. We'll just do like tens. So let's say I have my negative 58 over here. Here's my number line. Here's 0. This is 10, 10, negative 20, negative 30, negative 40, negative 50. We'll say this is negative 58 right here. Then we have positive 10. So this will be our positive 12 around this area, right? So if I have the difference between these two numbers, remember we talked about with the additive inverse, we had a fancy word, right, for the difference between 0 and whatever number we were getting to, which was the distance. So if I have the distance from 0 to negative 58, that's going to be 58 numbers, right? The absolute value here is going to be 58. And I have an absolute value over here of 12, right? And there's all of this distance in between negative 58 and 12. So this distance is equal to 70 because it doesn't take into account necessarily what these two numbers are, but how many numbers are in between them, right? That's what it means by like taking into account the absolute values of these numbers. So for number 3, the difference between the two temperatures is going to be 70 degrees. And it's going to be positive, right? 70 degrees is the difference. Go ahead, you can put in check answer. 1 point, awesome. And now we'll go on to question number 4. Unless someone has a question on number 3. No? Okay. Okay. So question number 4, it says select the expression equivalent. Remember, expression does not have an equal sign. So we're not going to find an answer to this. We're going to be simplifying the expression, right? So I have the parentheses, and we know with PEM does, we have to do our parentheses first. Let's write out what we have. We have, oh, dang it. X plus 3. In between the parentheses, I have another plus sign. In second parentheses, I have negative 2x. And then I have plus 4. All right, so we need to do the parentheses first. But with that, if I look here, I have a variable, right? I have an x. And when I have an x in my math problem and I don't know what x is equal to, I can't do any more math with it, right? It's going to stay 4x. So I have 4x plus 3, and if I don't know what x is, it's not going to get any simpler than 4x plus 3. But we did satisfy the rule of completing the math of the parentheses, right? And I'll show you guys what I mean by that in a second after we get this simplified. So my 4x plus 3, I can take that out of the parentheses. I'm going to set it down here. And then I have plus negative 2x plus 4. If I look at negative 2x plus 4, I have kind of that same situation, right? If I have negative 2x plus 4, I can't do any more math with this, right? I don't know what x is equal to. So I have satisfied the rules of doing the math inside the parentheses. So I have plus negative 2x. I put my 2x into the parentheses just so I make sure I don't lose my negative sign here with that plus sign. Okay, so I have negative 2x plus 4. I told you guys before what we can do and what I like to do usually when I have a plus sign and then I can't do any math inside the parentheses is I like to distribute the plus sign through the parentheses because we can almost think of it as like a +1 in front of the parentheses sign. So if I distribute my plus sign, my +1 times -2 is going to be equal to -2, right? And then +1 times 4 is going to be equal to -4. So it will look more like 4x plus 3 minus 2x plus 4. And now I'm going to combine like terms. Okay, if I combine like terms, that means that if I have a 4x and a 2x, well, -x, those are like terms, right? The x is stuck with the 4 and the x is stuck with the -2, so I'm going to combine those. So that's going to look like 4x minus 2x minus 2x. And then I have single integers, right? My +3 is a single integer. There's no variable attached to it. And then I have +4. There's no variable attached to the 4. It's just an integer all by itself. So 4x minus 2x, that will give me 2x. And 3 plus 4 is equal to 7. So I have +7. Okay, so select the expression equivalent to 4x plus 3, in parentheses, plus -2x plus 4 is going to be equal to d, right? 2x plus 7, that's what we got here. And I wanted to show you guys something. Let's say that I know what x is. They gave me the value for x. They told me that x is going to be equal to, let's use 5. Okay, x is going to be equal to 5. All right, so I'm going to plug 5 in for x. I'm going to plug it in for both the original expression and then I'm going to plug it in for my simplified expression. So you guys can see that's going to equal the same thing. Okay, so I have 2x, or 2 times 5, plus 7. So 2 times 5 is equal to 10, right? So 10 plus 7, that's equal to 17. All right, so let's plug in our x value, our given x value, into our original equation, which was 4x. So we're going to put 4 times 5 plus 3 then I have a plus sign, right, in between that is parentheses. -2x. I'm going to plug my 5 in. So that'll give me -2 times 5 plus 4 to complete that parentheses. Okay,
my internet was disconnecting. What question are we on?
Question number 4. Is your internet good now? Ready?
Yeah, but I did miss the answer for number 3.
For number 3?
Yeah.
70.
Okay, thank you.
You're welcome. Okay, 4 times 5 is 20. So I have 20 plus 3. Which is equal to 23. And for negative 2 times 5, that gives me negative 10 plus 4. So negative 10 plus 4, we know if we are adding numbers with opposite signs, we are going to take the absolute value of both and then subtract the smaller number from the larger number and take the sign from the greater number. So essentially we have, right, 10 minus 4. So we're going to find the difference. Use the sign from the larger number. So 6, and the larger number is negative, so that's negative 6. So I have 23 plus negative 6. Again, I'm going to be adding numbers with opposite signs. So I can do the same thing. I'm going to subtract the smaller number from the larger number when after I take the absolute values. So I'm going to have 23 minus 6. 23 is a larger number, which this is positive, so I will have a positive answer. 23 minus 6 is equal to 17. Okay, so if we look here with my fake x value, I got the same answer when I plugged in 5 here at my simplified expression, right? My 2x plus 7 gave me 17. And then when I plugged 5 into my original equation or my original expression, I got 17. And that's what it means by having an equivalent expression, is that when we plug in x, we'll get the same exact answer. Okay, so for question number 4, our answer is 2x plus 7.
Did you say C?
D. D is in dog.
D. Okay.
D.
I heard a C.
Oh, sorry. So now I'm on question number 5. All right, question number 5. I have negative 3.75 plus 2 parentheses negative 4 x plus 6.1 close parentheses minus 3.25x. All right, so according to our order of operation rules, PEMDAS, right? Parentheses are first. This is exponents. Multiplication multiplication, division, adding, subtracting. All right, so I have parentheses right there. I have negative 4x plus 6.1. Just like the last problem, I have a variable in there, so I can't do any more math inside of my parentheses. But in order to get rid of my parentheses, right, I need to multiply my 2 through, right? I need to distribute my 2 through the math problem. So that tells me I have 2 times negative 4x plus 2 times 6.1. So 2 times negative 4x, that's negative 8x, plus 2 times 6.1, that's going to give me 12.2. All right, so now that I distributed my 2 through, right, I have negative 3.75 plus negative 8x plus 12.2, and then minus 3.25x, okay? So now I need to combine like terms. That's what I did in my last problem, right? So now I'm going to combine the terms. So I'm going to look for any integers with a variable, right? Because I have an x here. Okay, so I see that I have negative 8x and negative 3.25x. So I'm going to combine those two. Negative 8x minus, right? So I want to take this with me, minus 3.25x. Okay, those are my only ones with variables, right? So here's my integers that are without variables. So I have negative, or minus 3.75. And then I have plus, right, take that with me, plus 12.2. So it says select all expressions that are equivalent to negative 3.75 plus 2 parentheses negative 4.6 plus 6.1 parentheses minus 3.25x. So I will have more than one answer for this. Okay, so right now, how it sits with negative 8x minus 3.25x minus 3.75 plus 12.2. None of my answer choices look like that, right? So we need to do a little bit more math before we can start selecting the correct expressions. Okay, so I have negative 8x minus 3.25. So I am subtracting numbers with the same sign. So that means my negative 8 is going to become greater in value on the negative side. So I'm going to have negative 11.25x. And then I have negative 3.75 plus 12.2. So I'm adding numbers of different sign. I'm going to subtract from the larger number. So 12.2 minus 3.75. I'm going to add a 0 here. So 0 minus 5 I can't do. I need to borrow 1, right? So I turn it into 12.20. So borrowed 1, 10 minus 5 is equal to 5. 1 minus 7 I can't do. I need to borrow 1. So I've got 11 minus 7, that's going to give me 4. 1 minus 3 I can't do, so I need to borrow 1. 11 minus 3 gives me 8. And this is positive. Right, because I took the absolute values and subtracted. I took the sign of the greater value, right? That was rule number 4 from our Nearpod, right? Adding rational numbers with different signs, find the difference of the absolute values, then use the sign of the rational number with the greatest absolute value. All right, so now I need to find my combination of my numbers with variables and my positive 8.4, right? So I've got my variables, my integers. So let's see, for my answer choices, I have 7x minus 2x, which can be 5x. So 5x plus 8.1. Is that an option that I have here? Because I have negative 11.25x. And that could be paired with minus 3.75 plus 12.2. Or I could have negative 8x minus 3.25x plus 8.45. So I can see that my first choice, 7x minus 2x plus 8.1, is not going to work out. It's going to be a completely different expression, so it's not equivalent. My next one, I do have 8.45, and then I have minus 8x minus 3.25. If I have minus 8x, that's going to be the same as negative 8x minus 3.25. So this one, my second option right here, is an equivalent expression, right? Because it's right here. I have 8.45. If I move this over here, it's 8x minus 3.25x. Okay, my next option is negative 1.75 minus 7.25x plus 6.4. So if I have negative 7.25x, but over here, my answer for the integer with the variable is negative 11.5x. That is my total with the x. So that won't work out, right? Because I have more than 7.25 times x, okay? I have negative 11.25x, so this does match this variable here. Then I have plus 12.2, which is right here. And then I have minus 3.75, which is right here. So this is also
We're back.
an equivalent expression. So there's these two. What was that? Sorry, was that Brody? Okay.
No, that wasn't mean. I think that was a Senlaria. I don't know.
Oh. If you have a question, you can unmute yourself. Sorry, I have my music on in the background. I just heard that I saw that someone unmuted and I heard a little bit of a voice. All right, so for my answer for number 5, the two equivalent expressions are the two that I have highlighted, 8.45 minus 8x minus 3.25x. And then I have negative 11.25x plus 12.2 minus 3.75. Okay. Check answer. Oh my gosh, we got it correct. Yay. All right, question number 6. Into the decimal equivalent of 11. All right, so we know that 11 over 8, that little line is the same or means to divide, right? So we have 11 divided by 8. And that is how we can get the decimal point, just by doing that simple math, right? So I've got 6. I have 8. Here's 11, so I am going to divide 11 by 8. So 8 goes into 1, that is 0, right? 0 times so far. So I drop that 1, drop the next one, right? Bring that one down. 8 goes into 11 one time. 8 times 1 is 8. So my remainder there is 3. So now I need to add a decimal point right here, right? Here's another 0. I'm going to drop that down. 8 goes into 30, 8, 16, 24, 32. Oh, too far. 3 times, right? So I need to bring my decimal point, right? Because I added 1 here. I need to bring that here. 8 goes into 33 times. So 8 times 3 is 24. 30 minus 24, that is going to give me, you borrow 1, 10 minus 4, that gives me 6. 8 does not go into 6. I'm going to add another 0. I'm going to drop that 0. 8 goes into 60. How many times? 8, 16, 24, 32, 40, 48, 56, 64, too far, so 7. Okay, so I've got 7. 8 times 7 is 56. 60 minus 56 is going to be 4. Okay, I'm going to add another 0. I got to drop that 0 down. 8 goes into 40, 8, 16, 24, 32, 40. 5 times exactly. Okay, so now I have a 5. 8 times 5 is equal to 40. All right, 40 minus 40 is equal to 0. So I can't add any more zeros because I'm just going to keep getting 8 into 0. So the answer here is going to be equal to 1.375. My decimal point value for 11 over 8 is 1.375. There we go. We still have 3 more minutes. That's okay, Erica. And then I'm just going to keep going. So if you want to stay and do all of the questions, you're totally welcome to. I'll keep the meeting going. If you don't want to, that's totally fine. Okay, so question 6, we got the answer was 1.375, right? Check answer. There we go. Yay, we got it correct. Teachers make mistakes too sometimes, so gotta check us every now and then. All right, question number 6.
Wait, it was 735?
Question number 7. Yep, 1.375.
Oh, 375.
1.375.
735.
I may have said it like that. I told you, sometimes teachers make mistakes.
I have to go.
Okay. If you have to go, no worries.
Tell them you have an emergency.
If you have an emergency, that's A-okay.
Okay.
Class is over at 11:50. I'm just going to keep going just because I know so many people needed help.
All right.
So no worries. All right. Have a good rest of the day.
Bye.
All right. Bye. All right. Question number 7. Enter the value of C when the expression 21.2x plus C is equivalent to 5.3 parentheses 4x minus 2.6. So we haven't done, did we do one like this together? I don't think so. All right, so we are going to be venturing into a little bit of algebra. It's fun, right? It's like a puzzle. Hey, Brody, you're still unmuted. Yeah, I got you, actually. Never mind. 21.2x plus c. And it says, enter the value of c when the expression 21.2x plus c is equivalent to 5.3 parentheses 4x minus 2.6 parentheses. And I told you whenever we have an expression, we don't necessarily have an equal point, right? Or an equal sign, because then it would be an equation. But we're going to have an equal sign here because we were given what our expression is equal to. It's equal to another expression. So 21.2x plus c is equal to 5.3 parentheses 4x minus all right. So we are going to kind of attack this one problem at a time. Bye, Ella. Bye, Erica. We need to start with our parentheses. Okay, on this side, I have 21.2x. I can't do any multiplication because I don't know what x is. And then I have plus c. I don't know what c is equal to, so can't really do anything there. I know what I need to do because the question asked me to find the value of c. I need to try to isolate c. When I say isolate c, that means I need to get c by itself. Like, so it's going to look like c equals blah, 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 right? This is what we want our end result to look like. Okay. But before I do that, I'm going to get this side simplified. Okay, so 4x minus 2.6. I can't do any more math, but I can distribute my 5.3. So that means I'm going to have 5.3. And I'm going to multiply that by 4x. Then I will have 5.3. And I'm going to multiply that. And I'm going to hold on to that sign when I multiply. I'm going to multiply that by negative 2.6. So I have 5.3.
What just happened? Did the teacher get kicked?
Oh, you're having that too? I thought it was just me. I thought my computer crashed, but I guess
Dude, I thought
crashed
so too
instead.
because of the time. I thought it kicked us out because we were being hold too long.
We've only been here for like 3 minutes. It's
Bruh.
only like 3 minutes past. Okay, what do? Do we private chat the teacher, say that she crashed the computer or she accidentally left? Or do we just sit here and wait? Or do we just leave?
Just put it in the classroom chat.
Oh, there she goes.
Bruh. Like, my screen froze. It looked like, oh, she was leaving. Did she just leave us? Are you kidding me?
I don't know what's going on.
How rude.
I'm confused now. I don't know if she did this on purpose or this was an accident. I don't even know anymore.
She's just like, okay, so I'm just gonna put my little cursor above the leave button. I'm gonna act like I'm still writing this. And the other hand,
She left the
what?
recording button on.
Oh,
still recording us. You can tell because the red dot's still red.
Busted.
We got caught in 4K.
Dang it. Just imagine that actually goes up in YouTube. Actually, I think it does.
Oh yeah, it does. I found the last video when I was absent.
We're gonna make the teacher famous now.
Okay, the first I'm gonna private chat the teacher asking her what happened.
Like, how is it still recording if she's not even in the meeting?
I don't even know. Like, I don't even know how the heck.
What kind of witchcraft is that? Everybody who's watching this right now, it's a commercial break.
I don't know what to do. I legitimately do not know what to do.
I told everybody it's a commercial break.
I mean, it kind of is kind of a commercial break, actually. This kind of reminds me of actually commercial break. So don't leave.
Bruh, even Davian's trying to leave.
I don't know if we're actually supposed to leave or not.
No, I'm staying.
I don't know if we leave like early, do we get in trouble? I mean, we can leave already. It's fully past time, so I can see why we can leave.
Yeah, but I kind of want to stay so I can get these answers, so I can get my B. And maybe I'll get extra credit for staying.
I don't know about staying extra credit. I never heard that before, and I did it before actually. I've actually managed to stay in the classroom, try and stay as long as possible, but then I had to actually leave. In reality,
Let's do it again.
nowadays
Let's
it just turns off.
Break the world record for COVID-19.
I don't know how to break that. What, you just get coughed on 100 times?
Bro, this is kind of sad. Nah, it's 1,000,000 times.
No. We can't do that. We can't do that. It's gonna take forever.
Okay, I'm bored.
Yeah, me too. But I've literally no
Bruh,
idea what to do.
David.
I don't know about 5K, 500K. I don't
Get
know
a
about that.
50% discount. Hey, you're back. Hey, wait for your god. We gotta make you a
Okay,
little bit famous.
you guys made me famous. I don't know. What does that mean?
Yeah.
We
We
told
had a little bit of
jokes.
comedy.
What did you guys do? Do I not want to know?
Told jokes. We
You
told
don't want
jokes.
to know.
Oh, thanks a lot.
We
You guys
didn't
know I
even
can.
notice the camera was still recording.
I am going to. I'm gonna watch it later. I hope you know that.
Yeah, I don't think I said
Oh
anything
boy, I'm
bad.
about to lose my grade.
Yes, my computer died, so that is what happened.
For the first split second, I legitimately thought my computer just crashed, but apparently it was just your computer just dying.
Yes, well,
Like,
I was.
thought.
I thought that something happened here. I thought the power went out, so I was like, "Well, look, guys," because one of the other teachers in here was like, "It's done," and so I thought everyone was experiencing like this power outage. I was like, "Oh no, my kids!" It was just me. I didn't turn my computer died. Okay, so apparently it's like still recording. So on my other computer, I guess.
This is so sad.
What's so sad? I can't reach.
Hey, at least the people who are watching this on YouTube gets a commercial break.
A commercial break.
We can't, but it was trying to kind of do like a commercial video.
Is that how you made me famous?
Yeah.
Yeah, a comedy commercial break.
Oh jeez. Okay,
Oh, it turned 12.
we will continue. Well, like I said, you guys don't have to stay the entire time. I can't believe 2, 4, 6, 7 of you are still here. It's awesome. Okay, so let me get reset up. Aww.
Well, I'm
My
gonna
daughter just texted me that she missed me.
1 hour later.
I will send you a very special message to the teacher, and I'm giving every teacher a very special message. I created
Thank you,
it,
Michael.
so you will get it in mail.
I'm gonna get it in the mail.
No, on like the computer on mail.
Oh,
I can't
okay.
figure out how to send
Email.
it. 'Cause
Okay.
I'm still trying to figure out how to do mail. Last time I accidentally shipped a package to the wrong address. I have no idea where it's at. I literally have
Oh,
no idea.
are you, Didi?
Did you just say
Are
you're
you?
still trying to learn how to do mail? Like
Yeah,
send
I
mail,
have no
yeah?
idea how to do that. I
Or
accidentally sent a package
like an
to the wrong
email.
place. Like the real life mail. I've been trying to do that, but I kind of messed up and threw the package somewhere else. I have no idea where it's at now.
That's so cute. Real
Pretty
life
cool.
mail. Yeah.
That
Dang,
would
real
be
life
pretty
mail.
embarrassing if you just sent like a letter to your girlfriend in the wrong address.
No, it was like a letter to the teacher. It was like a goodbye letter.
That is so cool.
I don't know if that's worse or better.
So I have this computer.
Why did you
Gotcha.
write a whole bunch of geography on the computer lid? I saw a whole bunch of math on it.
Oh,
just gave you the letter
geography. No, those are
from
math and
email.
physics equations.
I gotta go, everybody. Bye, everybody.
Bye. Bye, Michael. Have a good rest of your day. I will look in the mail for that letter. All right. Let me get back on this one. Okay.
You are muted. Bum ba bum bum.
Thank you. I didn't even realize I was muted. Thank you. All right, so we were on, okay, actually it's still all set up where I was before. Let's see, switch over the camera. Oh shoot, turn on the camera. I muted on purpose, so that way I wasn't chewing in your ears. You're welcome. Okay, so here is where we were at, and then I will share my screen.
You can see it.
There, perfect. And then when I do that, can you see the doc cam still?
We can see everything.
Perfect. Okay. Back to question number 7. We're isolating C, but we are simplifying our expressions. So we did stutter there. We distributed our 5.3 through the parentheses. That's right, that's what I was doing. I grab my phone, show you guys calculator. 5.3 times 4 is 21.2. I have 21.2. I tell you guys all the time, you guys can use a calculator. I want you guys to know how to not use a calculator. If you want, I can do the math. 5.3 times 4. I figured I'd save us some time. Do you guys want me to? All right. 5.3 times 4. We're going to use our decimal point trick, right? I have one number behind one decimal point. So I know that I need one number behind my decimal point. So I have 4 times 3. That's going to give me 12. Carry the 1. 5 times 4 is 20 plus 1. I have 21. Using my decimal point rule, I need one number. I have the decimal point, right? So I have 2, 1, 2. I start here. Here's one place, 21.2. Now, if I think about it rationally, 5 times 4 right here, right? Because I know that I have these two whole numbers. 5 times 4 is 20. So I know that my value, when I multiply these numbers, needs to be greater than 20, because this is equal to 20. And I had 5.3. 5.3 is greater than just 5. And I know that 5.3 is less than 6. 5 times 6 is 30. So I knew that my answer has to be less than 30, but greater than 20. 21.2 will work. Let's say we don't know the decimal place rule. I know that my answer should be somewhere in between 20 and 30. So if I had 2, 1, 2, that should automatically let me know that I'm going to have to put my decimal point right here to have 21.2. All right, back to the math. So now that I've distributed my 5 through the x, now I need to do 5.3 times 2. Six. That equals 13.78, but it's negative. So negative 13.78. All right. So now I've done all the math for my parentheses. I have 21.2x plus c is equal to 21.2x minus 13.78. I can't combine like terms here because I have one number with a variable, one number without, so I don't have like terms yet. I need to isolate c, meaning I want to get c by itself. In order to get c by itself, I need to subtract 21.2x, right? Because I need to get rid of it on the side. So I need to subtract 21.2x from here, and that means I will bring it over here. 21.2x minus 21.2x. All right, so now I can combine my like terms, right? Because I have variables right here. I have 21.2x minus 13.78 minus 21.2x. So I'm going to combine like terms. So I'm going to combine my x values. So I have positive 21.2x minus 21.2x minus 13.78. And since I isolated c, I have c is equal to all of this, right? 21.2x minus 21.2x is going to be equal to 0, though. Right? So these two away. So essentially, C is equal to negative 13.78. Because now I have 0 minus 13.78, making C equal to negative 13.78. Okay. You can go ahead and put that value in. Check the answer. I got 0 points. Hold on. What did I do wrong?
It's neglecting you.
I know.
And also, I don't see any like negative numbers in it.
What do you mean?
I don't see any negative numbers in the equation.
We have minus 2.6, right? 5.3
Minus 2.6.
parentheses. Yeah, so that gave us our negative.
That's 4 minus 2.6, like subtracting.
We have 4x minus 2.6. So if I have 4x, that means the 4 has a variable attached. That's why I said we need to combine like terms. There's no math that we can do with our 4x minus 2.6. So I can't just get rid of x and say that it doesn't exist and then take 4 minus 2.6. So my parentheses, I can't do any more math inside of it at this point when I have 5.3 parentheses 4x minus 2.6. That's why I distribute the 5.3 through, meaning I multiply 5.3 times 4x. And I did that. That's why I got positive 21.2x. 5.3 times 4. Then I did 5.3 times 2.6. And that gave me 13.78, but it's negative, right? Because I have minus right here. So I have 21.2x minus 13.78. My original problem was 21.2x plus c. So if I have 21.2x plus c is equal to 21.2x minus 13.78, I need to isolate c, meaning I get c by itself. And I don't just automatically assume x doesn't exist. X still has value. I just don't know what its value is. X is a variable. So now I need to subtract 21.2x from the side with c. That way I can isolate c, meaning I get it all by itself, right? I have it over here. Because the question is asking, enter the value of c when the expression 21.2x plus c is equivalent to 5.3 parentheses 4x minus 2.6. So when I went through and I subtracted 21.2x, I had to do the same thing on the other side. So positive 21.2x minus 13.78 minus 21.2x. I had the positive 21.2x minus 21.2x. That should have given me 0 minus 13.78. So C is equal to negative. Oh, you know why it's wrong? I didn't do a negative sign. I did minus as if it was an expression. One sec.
But huh?
I'll show you. Give me one sec.
Because you only have the under dash and then the minus sign.
The under dash is the reason why I got it wrong, meaning subtraction sign. So see right here, 13.78. Oh, it should be negative. When I entered in the answer key, I did positive 13.78. That's what's wrong. we fix it. See, I told you teachers make mistakes. Your guys are already in it. I can't change it. So go ahead and put in positive 13.78. The answer should be negative 13.78.
Okay.
Okay, but does that make sense to you, Brody, how I got negative 13.78? I noticed
Yeah.
on your homework that you would do that. If there was an x value, you would just subtract, but you need to keep the x, okay?
Okay. Yeah, because I don't like this kind of math because it always confuses me.
And it makes sense that it would confuse you because with Edgenuity, you guys got introduced into algebra and the concept of variables, but no one explained to you that this x has value. You just don't know what it is right now. That's why when I first started teaching you guys kept asking me, how do I know what x is equal to? But you don't know unless it says like x is equal to blah, 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 or the given value for x is so-and-so.
Yeah.
And when you
When I was
have
in,
these,
like, third grade, we would use these random letters, and it would just be just a random letter, no value or anything, until we got the answer, and then we would do something with it. So I thought that was going on, but I guess I was wrong, because I always got them wrong on my tests.
well, you know what, that is the random letters. It's actually totally right. There, you can use any variable in place of x. And then you just need to figure out what the answer is. And it's a hard concept to teach yourself, honestly. And that's why I wanted to spend more time together doing algebra before school was out, but we're at the very last day, unfortunately, so we won't be able to do that. But what's most important that I want you to gather from what we're doing right now is that x has value, or y, whatever variable is there. If a place with a variable, that means that you need to plug in a value for x. So it's almost like a placeholder for a number that you can plug in there to get an answer. I think that you may have your computer may have shut off, or you may have gone to the bathroom, but I showed you guys here for number was it? Number 4. When I talked about combining like terms, and our simplified expression was 2x plus 7. And I gave you guys a fake given. I said, let's make x equal to 5. And I showed you guys that if I plug in 5 for x, I'm going to get 17. And then going back to my original problem, if I plugged in 5, I still got 17. So think about x, or whatever variable that's in your problem, as like a placeholder for a value that could be given to you. Does that make sense? Yeah? Okay. I think that's what people struggle with most in algebra, is all of a sudden you're mixing in the alphabet. And the only reason why we bring in the alphabet in math is either for those rules where we have numbers, like, I guess even pi isn't technically, it's the Greek alphabet, but we're given a letter to represent a value, right? Pi is considered a constant, but the other times when we have a letter, it's just meant to be a placeholder. It's not meant to be a number that we know. That's why when I said for multiplication, we get rid of x and we add in the dot, because they don't want it to be confusing. But entering, adding letters into numbers seems to throw everybody off. All right, so we were on question number 7. Let's go to question number 8. And text my daughter back. Hold on. She said that she misses me.
When I saw number 8, I thought it meant
She's so cute.
that it was number A.
And
then
luckily 8
number
doesn't
B.
have A. All right, so for question number 8, as you can see here on the screen, I have all values equivalent to negative 10 over 7. All right, so with this, let's see, we don't have a decimal point answer. So we're going to kind of just go over each of these boxes. Fortunately, they're not labeled A through D, but my first possible answer is negative 10 over negative 7. And we talked about this in our last class period briefly when we talked about multiplying fractions, positive and negative fractions. If I have negative 10 over negative 7, and when I multiply two negative numbers, I get a positive. It's called the same sign rule. Since I have the same signs here, it is always going to be positive, right? So negative 10 over negative 7 is actually equal to positive 10 over 7. Okay, and that's using the same sign rule, what we went over last week in our near pod, rule number 8, right? All right, so our next value we have here is negative 3 and 1/7, which I could see how you could possibly confuse that for being correct, right? 10 minus 7 is equal to 3, but that's not how we figure out what our whole number value is, right? We need to figure out using division what our whole number value is going to be. If I have 10 over 7, it will look like 7, division sign, 10, right? I'm going to do 7 into 1. That will give me 0, right? And we're going to do one of these again. I drop the 1, and then I need to drop down my 0. 7 goes into 10. Let's see. One time, 7 times 1 is 7. Okay, so if I take 7, or 0 minus 7, I can't do that. I have to borrow 1, but it's 10, so 10 minus 7 is equal to 3. I am now going to add a decimal point, because I have to add a decimal point here, and I can drop my 0 down here. 7 goes into 30. 7, 14, 21, 28, 35, 5's too many. So go back to 4, that was 28. 4. 7 times 4 is 28. So 30 minus 28 is equal to 2. I can't divide 2 by 7, so I drop another 0. 7 goes into 20, 7, 14, 21, that's too far. So go back to 2, 7 times 2 is 14. 7 goes into 20, 2 times is 14. And we can keep going, right? Usually you want to stop until when you get to 0. That will be a complete decimal point. But I don't have decimals over here. But what I do have is I have 1 as my whole number. I know that I can't have negative 3 as my whole number because 7 goes into 10 only one time, not 3 times, one time. My whole number can only be equal to 1. But my next value is positive 1 and 3/7. I know that it has to be negative because I have negative 10 over 7. So this won't be correct either. My next one is negative 10 over negative 7. If I have negative, and this is negative 10 over negative 7 is equal to the positive 10 over 7, that's going to be the same as this, right? So it's actually going to be correct. It looks weird. It's technically correct. All right, and then my last option I have here is 1, negative 1. So far that's looking good, right? And then 3 over 7. All right, so in order to get my positive 1, I did the division problem, but what I could have done is I could go negative 10. Let's see here, I have the 7. If I take negative 10, and I look to see how many times does 7 go in here. 7 goes in one time. I have -10, and then I'm going to take away what I have of my 7, right? Because I have this whole number value here. So if I have my -1s over here, if I take 7 away from 10, that means my remainder will be 3 over 7. Because I pulled my 7 over 7 out, right? Because 7 over 7 is equal to 1. So I had -10 over 7, but I needed to subtract, which is negative, my -7 over 7, right? This then turns into my plus. 2 negatives make a positive in math. -10 plus 7 is equal to 3 over 7. Right? And I don't need 2 negative signs for my -1 and 3/7 because that whole value right there means that this whole number is negative. Okay, does that make sense? I got the remainder, my whole numbers. That means my correct answers are going to be the -10 over 7. Will be -10 over -7, and then the -1 and 3/7. Okay. All right. So number 9. Jenny has $25 and she earns.
Wait, what was the second one?
Oh, the second one is equal to these two.
Oh, okay. So it's D and F.
Yeah, I guess A, B, C, D, E. It'd be D and E.
Yeah, but like
But
some quizzes they put E as F.
they put E as F, or are you talking about like letter grades? A, B, C, D, F.
No, they put it as F. My elementary school, they would always do that for some reason.
Interesting. But then yes, D and F. All right, so number 9. Question number 9 says, Jenny has $25. She earns $10 for each lawn that she mows. Jenny wants to buy a concert ticket that costs $65. All right, so our knowns. She has $25 already. She earns $10 per lawn. So it says enter the minimum number of lawns Jenny needs to mow to be able to buy a concert ticket. The ticket costs $65. So essentially what we want to know is how many lawns does Jenny need to mow to get $65? She already has 25. All right. So let's turn this into an equation. I want $65. I have 25. I need, right? So that means I'm going to add, I need more money. I'm going to make $10 for every lawn that I'm going to mow, but I don't know how many lawns I need to mow yet. That's what I'm trying to figure out. So instead of having $10 times however many lawns that I mow, I'm going to give that a variable. I'm going to figure that out. I'm going to turn that into 10x, right? 'Cause I get $10 for every lawn I mow. If I mow 2 lawns at $10 each, I'm going to make $20, right? That means my x would be equal to 2. If I mowed 3 lawns, I know that I make $10 for each lawn that I mow, so that will give me 3 times 10, which would also be the equivalent to 10x. I just plug in 3 or whatever value I need as my x value, right? That's my placeholder. Brody, did you have a question?
No, I just wanted to make a guess on what it would be.
Oh, what's your guess?
4.
Oh, I was so excited. You're right. Okay. Let's see how Brody got 4. All right, so my answer, I know that I need $65 for my ticket. I already have 25. I need to isolate X, right? Because I need to figure out how many lawns I need to mow in order to get my 65 bucks. I don't want to make too much. I don't want to make too little, right? So I'm going to subtract 25 so I can isolate X. So 65 minus $25, right? 65 minus 25. 5 minus 5 is 0. 6 minus 2, that's 40, right? So I have $40 is equal to 10x. All right, so I still need to isolate x because I need to find what my value for x is. So in order to get rid of this 10 to isolate x, I need to divide by 10, right? Opposite of multiplying is dividing. So I need to divide the other side. I need to do the same thing to the other side, right? So I'm going to do 40 divided by 10. 40 divided by 10 is equal to what Brody said, 4. When I divided 10 from the x, that gave me x by itself, right? Isolated x. So 4 is equal to x, meaning I need to mow 4 lawns in order to get my $65. Great job, Brody. And your minimum number of lawns Jenny needs to mow to be able to buy the concert ticket is 4 lawns. Right? Make sense to everyone? Yes?
Yep.
Perfect. All right, so question number 10. All right, so question number 10. Enter the grams of peanuts in a bag for every 1 gram of raisins. See, what does the rest of that say? The table shows the proportional relationship between the grams of peanuts and raisins in a bag of trail mix. Like the 2 worst parts of trail mix. All right. So for every 14 peanuts I have, or 14 grams of peanuts, I have 4 grams of raisins. And for every 21 grams of peanuts, I have 6. So what I need to do essentially, right, is I need to pull one of my proportional relationships and apply it to enter the amount of grams of peanuts in a bag for every 1 gram of raisins. All right. So this is what I'm going to do. This I have for my peanuts. And this is for my raisins. And I'm doing this that way I can identify a pattern in my proportional relationship. All right, so for peanuts, I have 14 grams. And for the grams of raisins that correlate to the 14 grams, that's going to be 4 grams. Okay. My next value, that's going to be 21 grams of peanuts, and I have 6 grams of raisins. Okay, the next one I have 35 grams of peanuts, and I have 10 grams of raisins. So now I need to figure out what my pattern is. Like, how did I get from 14 to 21 to 35? And then 4, 6, 10. All right, so my first one, I see that I have plus 7 grams in between here. 21 to 35, I have plus 14 grams. Okay. See if I have 4 to 6, that's plus 2. Okay. In between 6 and 10, I have plus 4 grams. and I am looking for the ratio for 1 gram of raisins and peanuts, I'm not sure. All right, so I have 14 to 21, and then I have 7. Let me see, if I would have gone 14 plus 7 to 21, 21 plus 7, that gives me 28 grams. I have 2 and I have 4. Let's see, if I divide that by 2, that gives me 2. So what if I had 8 grams here? 28 grams would have been, let's see, plus 7. What if I started with 7 grams, right? Because right here I see kind of a pattern starting, right? I'm increasing by 7 each time. And if I am increasing by 2 down here, right? I could easily have a ratio that is 7 to 1, right? If I have, let's see, if I have 14 grams and I have 4 grams divided times 2 times 2, oh, I don't know, does that give me the right answer? 17 over 2 is the same ratio as 14 over 4. Right, here's 7 grams. I did plus 7. And here, I would need 2 grams, right, to get it to be plus 2. That's not quite right. But it's the only thing that makes sense, right? If I went plus 7, plus 7, plus 7, that means I need to probably divide, right? Because I need to get it to 1. So if I can see that my ratio is going to be plus 7 plus 2, right? Because if I do 7 and 2, and then I did 21 to 6, which that was one of my givens. My 35 and 10, that was plus 14, right? So in between, I have 28 grams and 8 grams. And that still fits the pattern that I'm seeing, right? Because I could see from 14 to 21, I had plus 7. Then 21 to 35, I had plus 14, right? And half of 14 is 7. So I knew that I could do plus 7 plus 7. Down here, I'm doing plus 2, plus 2, plus 2. But I need to figure out what I need for just 1 gram. So I'm down to 7 grams of peanuts for every 2 grams of raisins. Right, that's my proportional ratio, 7 to 2. But I need to find the equivalent ratio for something over 1. And in order to get 2 equivalent to 1, I need to divide 2 by 2. And I have to do the same thing to the top that I do the bottom, right? So that means I need to go 7 divided by 2 to get that. 7 divided by 2 equals 3.5. Okay, so that tells me that I'm going to have 3.5 grams of peanuts for every 1 gram of raisins. Does that make sense? I see that I'm frozen. Perfect.
Yeah, you're frozen.
All right. Hopefully you saw that explanation. So I identified my pattern. For every 7 grams of peanuts, I had 2 grams of raisins. So if my pattern was 7 to 2, in order to get to 1 gram of raisins, I had to divide both answers or both parts of the ratio by 2, right? Because 2 divided by 2 equals 1. So I have 7 grams of peanuts for every 2 grams of raisins. So 7 divided by 2 is equal to 3.5, giving me 3.5 grams of peanuts for every 1 gram of raisins. So my answer to number 10 is 3.5. I don't know how to make it unfrozen. There isn't like a refresh
Number
button
11
for
is super
Teams.
confusing.
Number 11 is super confusing? Okay.
Oh yeah, trust me, it is.
All right. Camera. Maybe if I try turning it off and then turning it back on, maybe that will help. All right, so for number 11, it says a bag contains 16 marbles. There are 5 blue,
Can you turn your
9
dot cam
yellow.
back on?
I will in 1 second. I turned it off and turned it back on, seeing if that will help freeze the screen. But yes, I will.
Yeah, it did.
Okay, so determine whether each statement correctly describes the likelihood of an event based on the given bag of marbles. All right, so I didn't finish reading the top. So a bag contains 16 marbles. All right, so for question number 11, bag marbles, and there's 16 marbles total. I have 5 blue. That means I have 5 out of 16 marbles that are blue. So I'm going to write that as 5 over 16. Right? I have 9 I have 9 yellow marbles. Probably can't read that. 9 yellow. So that means I have 9 out of 16 marbles that are yellow. And then last, I have 2 red marbles. Meaning 2 out of my 16 marbles are red. All right, so it says determine whether each statement correctly describes the likelihood of an event based on the given bag of marbles. Select true or false for each statement. So it is impossible that a green marble will be selected, true or false. Well, do I have any green marbles?
I don't know, do you? Did they give
No.
you an extra?
No, I only have 16 marbles. It says a bag contains 16. So if the bag contains 16, even if they gave me an extra, I wouldn't select that out of the bag because the bag contains 16 marbles. There's blue, yellow, and red. So it is impossible for me to choose a green marble because there isn't a green marble. So the answer is true. It is unlikely that a yellow marble will be selected. Well, if I look here at my ratios, if I have 5 out of 16 that are blue, 9 out of 16 are yellow, and 2 out of 16 are red, I have the most marbles in yellow. I feel like I'm saying that wrong. Most of my marbles are yellow, right? The greatest portion of my marbles are yellow. So it's not unlikely that yellow would be selected. It is most likely that yellow would be selected. That one is false, right? See, it's not that confusing once I say it like that, right? So it is certain that a blue marble will be selected. Well, it's not necessarily certain that a blue marble will be selected. There's 5. So you have 5 out of 16 chance that you'll select a blue marble. I mean, if you choose all or like draw until you get to a blue marble, then yeah, it is certain. But if you don't have that as a parameter, it is not certain that you will get a blue marble. So that's going to be false. It's a possibility. All right, so it is unlikely that a red marble will be selected. If I only have 2 out of 16 marbles that are red, that statement's true, right? Out of all 16 marbles, there's only 2 of them. It means that the likelihood of you selecting the red marble is 2/16.
We
Yes.
can only see your piece of paper, not the little test thingy.
Oh, I'm not showing my screen anymore. Perfect.
No.
All right, here you go. So I had said before, this one's true. It is impossible that a green marble will be selected. That is obviously true because we don't have a green marble. It is unlikely that a yellow marble will be selected. That's false because we have the most yellow marbles. Like we have more yellow marbles than any of the other marbles. I feel like I'm saying that weird. And then it is certain that a blue marble will be selected. It's not certain. If I only select one marble, I have 5/16 of a chance of getting a blue marble, right? And then it is unlikely that a red marble will be selected. That is true because we only have 2 out of 16. Our chances are 2/16 that we will get that red marble. That makes sense? It's not as confusing as it originally looked. It's all statistics. Right? All right, so question 12. Oh, someone has a question about number 11. All right, so question number 12. David goes into a candy store with $5. He buys 9 peppermints for 15 cents each. All right, so he has $5. Peppermints are 15 cents each. And he's going to buy 9 of them. All right, so 9 times 15 cents. And then it says, and some sour candies. Each sour candy costs 25 cents. Enter the maximum number of sour candies David can buy. All right. The sour candies are worth, let's see, sour candies are 25 cents. But we don't know how many he bought. All right. But we know, right? Let's set this up as an equation. We know that he has $5 to spend. So that means if he can spend $5, he is going to purchase 9 peppermints at 15 cents each, which mathematically will look like 9 times 0.15. Then he is going to buy sour candies. So we are going to add 0.25 times question mark, right? And let's just turn that into a variable. We can use x because we don't know how many David is going to buy. We don't know how much money he has left. He has to figure that out. So 9 times 15 cents, right? We can do the math like this, right? I have 2 numbers behind my decimal point. So 9 times 5, that is 45. 9 times 1 is 9, plus 4. That gives me 13. Carry the 1. 9 times 0 is 0, but I have plus 1. I have 2 numbers behind my decimal point, so I need to put my decimal point here. It's 1, 2, numbers behind it, right? So 1.35. All right, so $5 is equal to $1.35 plus 0.25 x, and I need to isolate x so I can figure out how much that is, right? So I need to subtract $1.35. It's going to help me isolate x and get this x value by itself. So $5 minus $1.35. 0 minus 5, can't do that. Need to borrow 1, right? 10. So 9 minus 5 is equal to 4. 9 minus 3 equal to 6. What did I do wrong there? 1.35. This is going to be 10 here. 10 minus 5, that is equal to 5. 9 minus 3, that is equal to 6. And 4 minus 1, that is equal to 3. 365. Right, so now I have 365 is equal to 0.25 x. And since I am multiplying x by 0.25, to get rid of it, to eliminate x, I need to do the opposite. So I'm going to divide both sides by 0.25. Right? And then that will tell me essentially how many sour candies I can buy with $3.65. So I'm going to go 3.65 divided by 0.25. That gives me 14. Let's see, let me write it. Where can I write that? You guys can see. That gives me right here 14.6 is equal to x. But if I'm at the store, right, and say I go over to Target, or actually Party City is kind of like where they sell individual candies, right? If I go over there and I'm like, hey, I only have 365 left, I want 14.6 candies, that's not possible, right? So the maximum number of sour candies I can buy is only my whole number value, because I can't go in the store and be like, hey, can I buy half that candy bar? So my maximum value is going to be 14. David can buy 14 sour candies. Okay, so maximum number, my whole number value, is going to be 14. So 14 is the maximum number of candies you can buy. All right, so right now it's almost 1 o'clock and I need to be in a meeting and get my angel face. So we're going to stop here at question number 13.
Okay, so what did we get for 12?
Number 12 is 14, because you can't go
14.
to the store and buy 0.6 of a candy bar.
Okay, and then for number 2, what was that?
Number 2,
Yeah.
go over number 2. Number 2, was 5 times, or parentheses, 13.5 minus 4.5. 13.5 minus 4.5 is equal to 9. So 5 times 9 is equal to 45.
So it's 45.
Correct.
Okay, and then for number 3, we got 70, right?
The difference between 12 and negative 58 was 70.
Okay, and then also for number 5, what did we get?
For number 5, okay, for number 5, we got, oh, that was the one that had a bunch of different answers.
Yeah.
We had negative 11.25x minus 3.5 plus 12.2. I believe it's like the second and the fourth options were the correct ones. So I had 11.25.
Plus 12.2 minus 3.75.
Yeah. And then the other one was 8.45 minus 8x minus 3.25x.
Okay.
Okay.
And then what was the next one?
Were you not paying attention this whole time?
No, my internet was being weird.
Oh, then you didn't learn anything. So you're just writing down answers. You didn't learn anything, Brody. To the point of like sitting here in classes to pay attention.
Well, my hotspot I ran out of gigabytes, so I had to reset it all.
So if you did that, how come you were in class the whole time? I didn't kick you out.
I don't know. It like, you know when like your internet goes down and it goes like,
Babe, my internet has
something went
never
wrong.
ever gone down, and then I've been able to stay in Teams. Like if my internet goes down, then my internet goes down and it kicks me out of Teams.
Mine doesn't do that. It gives me
Well,
some time to come back in.
so you have like magical internet that lets you stay on for Teams and nothing else? Because if you're in Teams, then you could hear me talking.
Because it goes like the free little things that says something went wrong, connect again, and it says dial in manually. And it does that for like 4 minutes before it kicks me out.
Oh, young man. All right. What's the next one that you need help with? Or that you didn't hear because of your internet?
It was number 5.
Number 5?
Yeah.
You know what's funny is the entire time that I was out, like not on the internet because my computer died, you were able to participate in making me famous, right, with your friends, but you weren't able to see the math. Just gonna throw that out there. No, it was not before I got kicked out because I would have heard you guys talking about me. All right, Bertie, I already gave you number 5. 8.45 minus 8x minus 3.25x.
Okay, thank you.
And then the second option was negative 11.25x minus 3. Or no, it was plus 12.2 minus 3.75. Do you, that's all you need?
Yeah.
Okay. Thank you for paying attention to the other ones. I appreciate you. And you did answer that one right, which was awesome. Okay, so then the rest of these, if you need help, then we can work on this tomorrow. Ask your teachers if you can pop in because I'll go over the rest in my other class. Since I got to record this, I'll have all the other students watch this recording and then we can go over 13 through whatever else. Okay, sound good? Perfect. All right, Brody, Landon, Damien, and Edcite, I will see you guys tomorrow.